Nice to be here. Thank you very much to the Pyth team for inviting me on. And I'm super excited to talk today about Gelato rollup as a service and also shine some light on how we've been working with Pyth so far at Gelato. So yeah, basically Gelato, some of you will know Gelato has been around for 4 years. We were the first ones doing smart contract automation. And since then also did relay account abstraction, serverless functions, which are actually heavily used by Pyth users to actually transfer data from the Pyth databases on chain. So that's actually pretty cool that that's already working in production for a lot of Pyth users. And then 2-3 months ago, we also launched our rollup as a service platform. And that's what I want to talk to you about today. So Gelato is Web3's cloud platform, and it's your all-in-one Ethereum rollup as a service. Yeah, so I'm Luis. I'm co-founder of Gelato, and yeah, let's go. So our hypothesis is that in 2 years from now, we will have 10,000 blockchains that feel like a single one. Basically, why do we need 10,000 blockchains in the first place, right? So basically, right now, what's missing to achieve mass adoption is that we don't have a good user experience. We lack scalability, and in terms of security, usually when you have a solution that tries to have better user experience and scalability, like any of the side chains, sometimes you usually lack security. So that's where sort of rollups come in, and rollups are really like the first time that we have technology where you can spin up a chain with high scalability, with great user experience, but you also retain the security properties of Ethereum or the underlying L1. Thanks to validity proofs. So we have seen this rise of layer 2s, and we've seen a lot of layer 2 frameworks gain popularity. So yeah, here you can see the rise of TVL on layer 2s. I think Arbitrum is like number 1 there. But overall, it's basically pretty clear that layer 2s rollups are amassing a lot of TVL, and that's a continuing trend today. So how does Ethereum scale with layer 2s? Essentially, we're going from monolithic blockchains to modular, horizontally scalable L2s. I'm sure some of you are quite like sort of believe in this modular blockchain thesis. Although, of course, there's other concepts out there, like Solana famously obviously doesn't embrace this so much. They try to go more for an integrated approach. But for the rollup technology, the modular sort of horizontally scalable approach is the name of the game. And essentially, how you can think of this is that Ethereum today has everything in one. It has execution, data availability, consensus, and settlement in one. It's trying to achieve that. Like, it's basically asking every node in the network to do all of these 4 things, which essentially leads to low scalability, as we've seen on Ethereum, of course. And the solution proposed by the Ethereum community, the so-called rollup-centric roadmap, is to essentially modularize the stack here. So to have execution happen on the layer 2, so on OP, Stack, on Arbitrum, Polygon, zk-Sync, all these sort of layer 2 frameworks. You have execution happen there. You have data availability modularized, and that is actually the main part that Ethereum wants to do in the future. It's already doing it, but it's quite expensive today. And with an upgrade called Dagensharding, it actually wants to be much cheaper here for data availability in the future. But you already have competitors here today with Celestia being live now, where essentially, these are layer 1 decentralized networks that promise you to make your data available, to give you very strong guarantees for that. And then you still have consensus and settlement. Here, Ethereum is definitely still like the absolute leader. That's essentially the layer where you deploy your assets on. Like the way I would describe Ethereum is like it's this decentralized asset layer. But yeah, so this is now modularized, roughly speaking, into 3 components. You have the execution happening on the rollup. That means we have a high scalability because as a rollup as a service operator, Gelato can essentially run much beefier machines and so on than any normal Ethereum node would be able to do. And we can really get high throughput with that and very cheap gas and so on. And we still use decentralized technologies for data availability and consensus and settlement sort of to retain the properties of decentralization. Essentially, you could say that execution becomes centralized or more centralized, and data availability and settlement remains decentralized. So how do layer 2s work? I mean, this is an oversimplification, of course, but essentially, users send their transaction to the L2. The L2 is just quite a centralized blockchain that is basically, able to scale on very big machines and to have a very high throughput. And then the whole purpose of having a layer 2, not just a centralized sidechain, is to actually over this blockchain, over this layer 2, compute validity proofs, so zero knowledge proofs, that we then post together with the transaction data to a decentralized network like Ethereum. And then you have this amazing architectural feature that you can basically execute in a like with high throughput, but you on the layer 1 you can sort of get your assets out in case that the layer 2 protocol sort of didn't follow the rules of Ethereum. In case there's any fraud or any breaches happening on the rollup, you can always get your assets out on the layer 1, and there you don't need to rerun the whole blockchain again. You just have these very succinct zero knowledge proofs that you can verify very cheaply on chain. And they sort of, you can think of this as sort of compressing, like really compressing the layer 2 blockchain onto the layer 1, so that on the layer 1, if you want to leave the layer 2 because of, for example, fraud, the layer 1 will release your assets, and the layer 1 can verify the validity of the layer 2, and it can also verify that fraud happened. So that's the idea. Yeah. So there's two classes of rollups really. So you have rollups and validiums. And at least in the zero knowledge world, I guess in the optimistic world, you would call them rollups and plasma or something like this. And basically, the difference here is that rollups are embracing more this sort of layer 1 Ethereum data availability and settlement. They sort of, they both post their data on Ethereum, but also settle on Ethereum, versus validiums that say, okay, they're even more modular, where they say, okay, the execution is happening on the layer 2, and we actually use another data availability layer that is not Ethereum. So that this could be very centralized, something like storing the data on AWS or like on a data availability committee, or it could I guess, like other alternative data availability layers that aren't Ethereum are also sometimes considered to be validiums. So what are the main differences? The main difference is rollups have better sort of, I guess, better security / decentralization guarantees, but they're also much more expensive. And validiums sort of lean one more step into this rollup modular architecture by saying that ultimately just the settlement needs to happen on Ethereum, and we can decrease the gas cost even further and have higher throughput by not storing all of the data on Ethereum. That's basically it. So ultimately with rollups, it always depends on what you really want. Do you want to really build new applications, app-specific chains that feel much more like a Web2 application? They are much faster, much cheaper, and so on. You can actually pay for all of the user's gas, but you trade off a bit of sort of security and liveness. Then you should probably go for a Validium. If you want to build a rollup that has very similar guarantees to Ethereum itself, but is still a bit cheaper, but not that much cheaper, then you just go for a rollup. Depends obviously on your use case and your needs for security and liveness. And then you also have a key difference in proving systems between optimistic and zero knowledge rollups. And their optimistic rollups basically are today much cheaper to run because they don't expend compute cycles on generating zero knowledge proofs all the time, which is today still quite expensive. Although we believe that zero knowledge technology will have something equivalent to Moore's law, and it will quickly catch up and become much cheaper to generate these proofs. But optimistic rollups have this sort of benefit that you don't have to generate a proof all the time. You only have to generate a fraud proof in the event that you detect a fraud. So they're in general more cheaper and less complex to run. But they have the obvious disadvantage to zero knowledge that you have this very long delay period to settle on the L1. Like commonly it's 1 week. So one of the key advantages of rollups is that you have this trustless bridge between Ethereum and the rollup, so you can move your assets very securely between Ethereum and the rollup. But the way back to Ethereum is the hard part, and their optimistic rollups, if you use the rollup bridge, take 7 days. So that's way too slow normally for any user, versus zero-knowledge rollups nowadays take like 30 minutes for the withdrawals. But this could also be much faster in the future. So yeah, that's the trade-off. In general, zero-knowledge rollups, I think, are the future. Optimistic rollups today are probably in their roadmaps also moving to some ZK technology in the future. It's just that currently zero-knowledge rollups are very expensive to run, and optimistic rollups in this state of the market are attractive because they're much cheaper and less complex. Yeah. But again, zero-knowledge technology is, I mean, it's there today already, and it's definitely the future as well, and it will also get cheaper. So who should launch their own chain even? Like, who should use Gelato RAS? And actually, we believe that most Web3 apps will benefit from high throughput, lower costs, and enhanced user experience. And yeah, so this means that perpetual DEXs, like DYDX has famously pioneered this with their app chain. Perpetual DEXs should definitely launch their own chain. They can have they really need a low latency. I mean, Pyth knows this. Pyth obviously pioneered the low latency oracles. Yeah, an Oracle provider like Pyth can also function much better and really provide the freshest data if the block time is simply like below 1 second and so on. So perpetual DEXs should all have their own chain. DYDX already has this. No wonder that they're also the most used one, but I'm sure like many other perpetual DEXs will follow. Web3 games definitely need their own chain. Like for on-chain gaming, you simply need very low gas cost and very fast interactions for the game to not suffer in user experience. NFT marketplaces where you have a bunch of mints and trades going on can also use their own chain. Social media platforms like Lens definitely should have their own chain. Enterprise blockchains actually are interesting because they normally need their own chain purely out of compliance reasons and so on. They simply cannot operate well on a public blockchain. They need to have some compliance with regional laws. Like, for example, in Europe, you have very strong user data privacy protection laws where you need to configure your chain in a certain way that you comply with these laws. Then ecosystem chains, like we've seen this with Base, right? Like if you, and actually on Gelato Rollup as a service, you also have Astar, which is a very big ecosystem chain in Japan. So yeah, if you have your own ecosystem, you really, can sort of cater to that experience, to their vibe on your own chain. Payments, we see this coming. There's more and more sort of payment solutions coming on chain, like Gnosis Pay, for example. I think Coinbase also has something. They should definitely have their own chain because they, again, need very high throughput and low latency. And just for the payment use case alone, they don't need to be integrated synchronously into any other DeFi application. So yeah, use case specific things definitely need their own chain. And then you have vertically integrated DeFi. So like these so-called super apps where you have maybe lending, like you have one provider, like I guess Meld or Frax, actually, for example, one provider doing swapping, doing lending markets, doing stable coins. So if you have this sort of super app, then the super app should also live on its own chain because you don't really integrate much with other providers. You sort of build everything yourself. So you might as well just do it on your own chain and not be bogged down by congestion or so that is coming from other apps that you have nothing to do with. Yeah, so required infra to run an L2, I mean, this is for the infra buffs, but you basically just need some JSON RPC nodes. You need a zero-knowledge prover, sequencer, and some other things. And then, very important, the additional services you need to have are like block explorer. So people often forget this when they think, oh, I'm just going to launch my own chain. Actually, what Gelato provides here is integrations with so many services like block explorers, TX debugging tools, indexers, oracles, bridges, relayers, keepers. So actually, I think all of these additional services really make the meat of what a chain is. The chain itself is not that interesting alone. You really need these key services like Pyth, oracles, for most chains to even be considered valuable at all. And that's sort of also what we've specialized in as a rollup as a service provider, is sort of building these integrations to these service providers. So yeah, Gelato rollup as a service. As I mentioned, these slides, I think we have a new version of them because we're not introducing this. This is already live for a couple of months. But essentially, what we do is we combine our Web3 middleware services, so Relay, automation, and so on, with layer 2 frameworks, OP Stack, Polygon, ZK EVM. And what we want to provide is like the sort of full stack hosted rollup as a service platform where you can sort of, as a application developer or as an ecosystem chain or protocol, you can go to our platform and you can pick your data availability network like Ethereum or Celestia. You can pick your execution stack, OP stack, Polygon or whatnot. And then you can also pick your sort of native Gelato services. So account abstraction, automation. Then we obviously have our Web3 functions that work with Pyth really well. And then on top of that, you have third-party middleware services like bridges, indexers, and so on. So we want to sort of provide a platform where people that want to launch their own chain, they can come and they can select amongst all of these stacks and providers, and sort of from day one, they can have a chain that, an OP chain or a Polygon chain that settles on Ethereum or Celestia and that already has Pyth oracles and so on baked into it as well. We want to make that as easy as possible. So yeah, benefits of Gelato RAS are that it's basically you can launch your application and you can really reduce the cost. Like if you're sponsoring gas for your users, which you probably should to really get more users in, the costs are as low as 1 cent per transaction. I think nowadays with Celestia being live and so on, we can even have sub-cent per transaction, or even like things that we call zero gas rollup, where you simply don't pay for gas at all anymore. You can have fast and scalable rollups, like much higher throughputs than you observe on any of the chains today. You can have Web2-like UX built into the rollup with native account abstraction. And yeah, like we even work on this sort of one-click deploy environment where you can quickly deploy your chain and test with it and see how much of a difference it makes to your application. So yeah, here's just like a sort of ecosystem map of all of the solutions that we sort of provide. Actually, this is also a bit outdated, but anyways, execution layer is we provide today OP Stack, Polygon, CDK, and Arbitrum Orbit. Data availability layer, we have Ethereum, Celestia, and Avail. And for indexers, we work with Gold, Sky, and the Graph, block explorers, and oracles. I think actually to be honest, we work most with Pyth and Redstone so far. Yeah, super excited about our partnership with Pyth. We have actually a lot of users already today using Pyth low latency oracles with our Web3 functions. So yeah, we already talking to the Pyth team to see how we can make Pyth like a really strong baked-in solution. I think especially for our perp DEX rollups that are coming live. We have a lot of cool ideas for how we could even integrate Pyth oracles deep into the sequencer layer so that the data is really fresh at the top of the block. We can experiment with things like MEV protection by giving Pyth oracles the #1 slot in the block and so on. So super excited for our partnership with Pyth and to see what we can build together here. I actually met the team in Istanbul and it was great meeting them as well. Yeah, and then bridges, we also work with Layer 0 and Socket and so on, and Connext. And yeah, essentially we're just trying to find the best providers in each segment and give our users that want to launch their own chain, give them the best option for that chain. Yeah. Yeah, so this is our ecosystem map. That's just the projects that have already used Gelato's middleware services in the past, and obviously PancakeSwap is one of them, Synthetics. I usually say that pretty much every big project has used us in the past, but also smaller projects have. So yeah, super happy to be working with all developers and yeah, people building in the space. And Gelato's been around for 4 years, so yeah, always a pleasure working with you. And feel free to reach out to us on our Discord or Telegram if you want to build something with Gelato or Pyth. You should definitely reach out to us. We have a lot of developer relations and developer advocates, people who can really help you get started. Yeah, at Gelato Network on Twitter, and there you can also find all of our links to Discord and Telegram and so on. So yeah, thanks a lot for having me on, Ed and the Pyth team, and super happy to answer any questions if that is possible at all. All right, then I think no questions. In this case, I will leave. See you soon, guys. Bye-bye.